Another hey from West Virginia. Okay, nope. Well, what I do have right though is joke of the day, and I know that you're ready and waiting for it because it's the best part of the day. And so this one is a shout out to my father-in-law, one of his most famous jokes. Here it is for you, Popsy. So what does a 500-pound canary say? A 500-pound canary? Chirp! That's for you, Popsy. Okay, well, what we are going to do now is we are going to divide fractions. And what you need to understand is that the idea of dividing is portioning out. It's dividing out into groups. You're taking things and you're spreading them out, splitting them up into groups. So when I'm taking a look at these examples of dividing, and what we're going to do is we are going to generate the steps for dividing fractions by working through the examples, just like we did when we were learning how to multiply fractions. So in this first example, it says I'm going to take a half and I'm going to divide it by 2. And what that means is I'm going to take a half and I'm going to divide it into 2 sections. Well, here I have a piece that is a half. If I take this half and I rip it, and I don't want to rip it because I love my little marker here, but if I rip it and I divide it out into 2 pieces, what's going to happen is each piece is going to be about this big. Well, you'll notice that that is the equivalent of your 1/4 piece. So in other words, this 1/2, if I divide it into 2 sections, each of those sections is going to be 1/4. Now, by the same token, let's say in this problem it says I'm starting with 3/4. So here's my 3/4. I'm taking these 3/4 and I'm dividing them into 3 sections, splitting it out into 3 groups. So if I have these 3/4 here and I'm spreading them out into 1, 2, 3 groups, that means each group is going to be the equivalent of, yet again, a 1/4, which is coincidental. Now, before we get into that last one, let's take a look at what we've done here and let's see if we can come up with the rules for dividing fractions. Now notice that I think that there is a way perhaps that I can manipulate these numbers to create a 1/4. Well, I do know that 2 times 2 gives me 4. But how am I getting that 1? But notice here that if I take a 3 and divide it by 3, I get a 1. So what do you, how can I manipulate this right here to turn it into 1/4? And like I said, 2 times 2 will give me a 4. Aha. What about this idea? What if we keep the 1/2 as it is, and we take this 2, which is technically a 2/1, and we flip it over, and when we flip it over, and I'm going to write this over here now, 1/2 of there, this is the first fraction. I'm going to flip this over like this, and then how would I manipulate a 1/2 and a 1/2 to create a 1/4? Well, I could go, you could say, well, if I add 2 and 2, I'll get a 4, but if I add 1 and 1, I get a 2. That's not going to work. But what if I multiply? Now, 1 times 1 will give me 1, 2 times 2 will give me 4. Aha, there's my 1/4. So it appears that my rules would be to take the second number and flip it and turn your problem into a multiplication problem. Let's see if that's the case with this one. So here again, what we think is the rule is to keep that first fraction as is, to flip the second fraction. Now currently it's going to be a 3/1, so if I flip it, it's a 1/3. And we said let's turn it into a multiplication problem. Now remember, we already know how to multiply our fractions because you are in my math gang. It's a fun gang to be in. So remember, my math gang says when we multiply fractions, we're going to cancel in those diagonals. We're going to cancel up and down, and then we're going to shoot straight across. We're going to multiply across the numerator, multiply across the denominator. So therefore, what I'm going to do here is I'm going to say, let's cancel the diagonals. 3 goes into 3 once, 3 goes into 3 once. Check this diagonal, nothing happens here. And remember, check up and down, always check up and down, so it'll be simplified in the end. 1 and 4, nothing happens. 1 and 1, nothing happens. So now I'm ready to shoot straight across, and I'm going to multiply across. 1 times 1 is 1. 1 times 4, aha, 4. So those are, in fact, the steps for dividing fractions. And notice, like I said before, a lot of people, they get this anxiety about math because they say there's just entirely too many rules and I can't keep the rules straight. All we did was add 1 new piece. And then we kicked back to some old rules that we had because we said go back to those multiplication steps. Go back to the rules for multiplying fractions. We only added one new piece. And that one new piece said we are going to multiply by reciprocal of the second. Multiply by reciprocal. Oh my goodness, I cannot spell. I'm so sorry. Reciprocal of the second. And remember, the reciprocal means we are going to flip it. So you always flip the second and turn it into a multiplication problem. Now, what a lot of people call this is copy, change, flip. And I'll put that in a different color so you can see it a little bit better. Copy, change, and flip. Because you copy down the first fraction, you change it to multiplication, and you flip the second fraction. And that is exactly what we said right here, and we go back to our multiplication rules. So let's take a look at this one. If we're going to do copy, change, flip, then what's going to happen is we're going to copy down the first one, we're going to change it to multiplication, we're going to flip the second one, which is currently a 5 over 1. When we flip it, we get 1 over 5, and now we go back to those multiplication rules. There it is again. Oh yeah! Cancel those diagonals. Cancel up and down. Multiply, shoot straight across. So we're going to cancel here, but nothing cancels. We're going to cancel here, but nothing cancels. We're going to cancel up and down. Nope, nothing. Cancel up and down. Nope, nothing. Now we're going to multiply across. So when we multiply across the numerator, I get a 1. Denominator, 5 times 3 is 15. There it is. The beauty is because we canceled on the diagonals, because we canceled up and down, I promise you 100% guaranteed that is simplified. All right, so let's take a look at a couple other examples just to make sure that we feel very comfortable with this. You know I like a lot of examples so that you feel confident in what you're doing. So here again, I'm dividing fractions. All I have is multiplication rules. So I'm going to copy, change, flip. I'm going to copy down the first one, change it to multiplication, flip the second one, and go back to my multiplication rules. I'm going to cancel on the diagonals, cancel up and down, and then I'm going to multiply across. So as I check this diagonal, nothing will go into 5 and 8. When I check this diagonal, aha, 9 will go into both. 9 goes into 9 once and into 18 twice. Now remember, always check up and down, because if you check up and down, I promise you 100% guarantee it will be simplified in the end. You won't have to think about it. So 8 and 1, nope, nothing cancels. 2 and 5, nope, nothing cancels. So now let's shoot straight across. So 8 times 2 will give me 16, and 1 times 5 is 5, and there it is. Now, rule of thumb is, if you start with mixed numbers, you need to end with mixed numbers. If I would have started with mixed numbers here, I definitely would have needed to convert that to a mixed number. In order to convert it to a mixed number, I always divide up, and I would do 5 goes into 16 3 times with a remainder of 1, and I'm going to keep my denominator because it's the superhero of fractions, so I'm going to keep it. But I did not start with fractions. So I did not start with mixed numbers. So I don't have to end with mixed numbers. This is something you can do if you want to, but I can leave it here. What you absolutely always have to do is simplify your fractions. Always, always, always see if they will simplify. In other words, reduce. That's a guarantee. All right, so let's take a look at this last one. Remember, dividing fractions, I don't have any rules for that. So I've got to convert it to a multiplication problem. I'm going to copy, change, flip. Copy the first one, change it to multiplication, flip that second one. So now what I'm going to do is I'm going to go back to my multiplication rules. I'm going to cancel on those diagonals. I'm going to cancel up and down. I'm going to shoot straight across. I know I look ridiculous. It's okay. I don't care. I just want you to learn the math, whatever it takes to learn the math. So when I check this diagonal here, what will go into both? 2. 2 goes into 2 once, 2 goes into 8 4 times. When I check this diagonal, what happens? Oh yeah, 3 goes into both. 3 goes into 3 once, 3 goes into 9 3 times. But don't forget, as crazy as I look, check up and down, because 100% guarantee it will be simplified in the end. 1 and 1, nothing happens. 3 and 4, nothing happens. I am ready now to shoot straight across and multiply. So I'm going to multiply 1 times 3 is 3, and in that denominator, 1 times 4 is 4. Voila, there it is. Now, I do want to caution, be very careful, because a lot of people get excited about this whole cancellation thing. And say, for instance, in this one, they'll start canceling right here. And they'll say, wait a minute, 2 goes in each of these. Or here, another thing they'll do is they'll cancel across. But you never cancel across. You remember, I know it's silly, but if you're in my math gang, then we are going to cancel on the diagonals. We're going to cancel up and down. We don't cancel across, we multiply across. So never cancel across, only cancel on the diagonals and up and down. So I hope this helps with dividing fractions, and hopefully you're seeing that really it's not a big deal because you're just adding one new step, that's all. So that you can convert it back into a multiplication problem. Copy, change, flip. Multiply by the second one and then go back to your multiplication rules. I hope that helps. Have a great day.